Currently, your reactions will be categorized in the following 5 types: synthesis or combination, decomposition, single replacement, double replacement, and combustion. A synthesis reaction is also known as a combination reaction. Synthesis is defined as something to build. So you could have an element such as A combined with an element B to produce a compound AB. So the elements combine to make one bigger product. Or you could have a compound such as AB and an element to make a larger compound. Or you could have multiple elements to make a compound. So the general format for a synthesis or combination is you can have an element and a compound plus an element or a compound and so forth, and it will just produce a larger compound. The second type is decomposition. It is the opposite of synthesis or combination. The word decompose means to break down. So in general, you're going to start with a compound and it's going to become smaller elements or an element and a compound. So you could have AB, which is a compound, breaks down to element A and B. Or you could have compounds ABC and it could become an element and a compound BC. Or you could have a compound ABC and it will break down to smaller elements A, B, and C. So general format is you're going to always start with one compound on the reactant side and you're going to end up with an element and a compound or plus an element or a compound. Single replacement reactions, there are 2 types. Cationics. In the previous chapter, we learned cationics are ions with positive charges. And the positive charges are metals. You'll have an element plus a compound that will produce a new compound and a new element. So element A replaces element B to combine with C to produce compound AC, and then B is left over. We know when we have a compound that is an ionic compound, the first element is always a metal unless it's ammonium, and the second one is always a nonmetal or a polyatomic. So here, when we have the new compound AC, the first one is going to be a metal or ammonium, and the second one always is going to be a nonmetal or polyatomic. A replaced B, A must be a metal. Why? The last compound, A comes first. Metals always come first in our ionic compound. So when an element is a metal and it replaces a metal of the compound to create a new compound, this is cationic. Anionic, remember, are ions that are negative charges, and these were the nonmetals. The format is still the same. D is still an element. BC is still a compound. BD is still a compound. C is still an element. So we still have an element and a compound at the beginning, and at the end we have a new compound and an element. Here, D is a nonmetal. Because if I look at the compound BC, again, the first one is a metal or ammonium. The second one has to be a nonmetal or a polyatomic. So if we create a new compound, the first element, again, has to be a metal or ammonium. and the second one has to be a nonmetal or a polyatomic. So if you notice, D replaced C and combined with B. Since D replaced C and C was a nonmetal or polyatomic, D has to be a nonmetal, and C is the new nonmetal by itself. Most of single replacements are oxidation reduction reaction, which means that one element will lose electrons and the other element will gain electrons. For this unit, we are not going to do oxidation reduction reactions. If we get to it at the end of the year, we'll spend a whole unit on it. For single replacements to occur, you need to look at the activity series. The activity series chart, the one I gave you in class, is the one I will provide for you on all your tests and quizzes. If you are in regular chem, all your single replacements will work. Honors or AP, you need to check the activity series to make sure the reaction occurs. If a reaction occurs, the element must be higher than its ion form on the activity sheet. If there is no reaction, the ion will always be higher than the element. So in this first example, potassium plus aluminum chloride. Potassium is an element, aluminum chloride is a compound, so we know this is a single replacement. How do we know if the reaction occurs? We look up the element potassium on the table right here. Since potassium is a metal, it's going to replace the metal in aluminum chloride, which is aluminum. So we look up aluminum. Aluminum here is an ion. It has a charge of 3 plus to combine with Cl, which has a charge of -1. Since the element is higher than the ion because it has a charge, this reaction will occur. So there is a reaction. Pause the video, try the next 3 on your own, and then check your answers. Calcium and hydrochloric acid. So calcium is an element. Hydrochloric acid is a compound. Calcium here is a metal. So we look up calcium on the table, which is right here. Hydrochloric acid is a compound. When hydrogen is in front, it behaves like a metal. Here, hydrogen is an ion. It has a charge of +1. Chlorine has a charge of -1. So you crisscross, you get HCl. So if I look up hydrogen, which is down here, the element, calcium, is higher than the ion. So this reaction will occur. Lithium bromide plus iodine. The lithium bromide is a compound. Iodine is an element. Remember, iodine is a diatomic. When it's alone, it occurs in pairs. So we know I2 is a nonmetal. So the nonmetal must replace a nonmetal. Here the nonmetal is bromine. In a compound, bromine takes a charge of -1. Lithium has a charge of +1. So if I crisscross, this is LiBr. Since bromine is a -1, this is my ion. So I look up bromine and I look up iodine. Iodine, which is the element, is lower than bromine. So this is no reaction. Lead 2 chloride plus hydrogen. Lead 2 chloride here is a compound. Hydrogen here is an element. Hydrogen is also a diatomic. Here, hydrogen will behave like a metal because if I look at my products, the hydrogen and the lead change position. So here it will behave like a metal. So it's going to replace lead, which is the metal here. Lead here, when it combines, has a charge of 2 plus. Cl has a charge of 1. Crisscross PbCl2. So I look up lead. Lead is here. Hydrogen is here. The element is not higher. Hydrogen is your element. It is lower than the ion, so this is no reaction. So for a single replacement, you need to use the activity series. Remember, the element must always be higher than the ion for the reaction to occur. Double replacement will start with a compound and end up with two new compounds. AB is a compound, CD is a compound, CB is a compound, AD is a compound. The easiest way to see this is the metals will swap partners. So in this case, A and C will switch partners. Since C is a metal, C's new partner is B, so the metal always comes first, and A's new partner is D. You could think of it as if you go to a dance as a couple, but then you swap partners in the middle. That is a double replacement. The last type of reaction is combustion. For any combustion, the following will always be true for you. It will react with O2 and it will always produce CO2 and H2O, no matter what. All combustion reactions for you in this class right now will start with a hydrocarbon. A hydrocarbon is a compound that has a carbon and a hydrogen. The X and Y could be any subscript. The other ones that you will see is usually alcohols, which is C, H's, and O's. And again, the subscripts could be any numbers. Pause the video, identify the type of reactions, and check your answers. HCl is a compound. NaOH is a compound. Produce two new compounds. So this is a double replacement. The hydrogen behaves like a metal here. Sodium is a metal, and what they did was they swapped partners. So Na's new partner is Cl. H's new partner is OH. Remember, we could write water as HOH. We have an element here. We have an element here. And one big compound at the end. So this is a synthesis or a combination. Here we have a compound. And we have another compound. And at the end, we have a new compound and a new compound. So this is a double replacement. So hydrogen here for acids behaves like a metal. It swaps partners with magnesium. So magnesium new partner is phosphate right here. And hydrogen's new partner is hydroxide, which can be written as HOH. Number 4, this is a combustion. O2 produces CO2, H2O. This is the hydrocarbon. This is the CX, HY. It could be any subscript. Number 5, this is decomposition. Start with one big compound here and ended up with two elements. Number 7, ammonia is a compound. Hydrochloric acid is a compound. It produces one large compound. This is a synthesis or a combination. Magnesium is an element. O2 is an element, a diatomic. One large compound here. This is again a synthesis or combination. We're going to drop 9. Number 10, we have a compound plus a new compound here. They're going to produce a new compound and a new compound. So this is a double replacement. Metal in the front. Remember, hydrogen behaves like a metal in an acid. Swap partners. So aluminum's new partner is sulfate and hydrogen's new partner is water if we write it HOH. Number 11, this is a combustion reaction. O2, CO2, H2O. The first part here is a hydrocarbon is CX's HY. If you combine this is C, 1, 2, 3, 4 carbons. Hydrogen, there's 3, 3, and 2, and 2, 10. So this is butane.